Okay, this is a continuation of z-scores, and in this case determining extreme values. I asked you to go over this just to think about in terms of what would be the right answer. And the correct answers for these, for the first one with 84 hours, the z-score would be 0.33, and that would be somewhere about right here close to 0, so that doesn't appear to be too extreme. But with 110 hours, if you take that and get the z-score for that, that would be 4.1, and that is over here on the far right. And so that example would be very extreme. Okay, so now here's an example where here's some famous baseball players, famous hitters from baseball. Ted Williams, Rod Carew, George Brett, and Tony Gwynn. And you can ask this question: who had the best baseball season batting average? Now, Ted Williams is the last person that they say batted 400 at least every time he got on. Every time he was at bat, he got on base at least 40% of the time. However, we can look at it from a different perspective. We can say, okay, if we know all the mean batting averages for their particular seasons, Ted Williams was 1941, Rod Carew was 1977, George Brett, I believe, was 1980, and Tony Gwynn was 1994. And we got the means for each of those years and the standard deviations. We can calculate a z-score to see what would be, or which of those batting averages would be more extreme. Now, all of those in each of those seasons were very extreme. But if you calculate each of those, you will find that here are the z-scores for each of these. All of those are pretty high. All of them are at least 3 standard deviations away from the center. But the one that went beyond 4 was Rod Carew. So even though Ted Williams broke the 400 barrier in terms of batting average, you could say that Rod Carew broke the z-score batting average for a particular season of 4, and so that's something no one really talks about it, but that's something to consider, that Rod Carew perhaps had the best baseball season relative to everybody else in that given season. Okay, so now what I'd like to do is I'd like to talk about converting z-scores to probability. Okay, now there's 2 steps to doing this. First of all is to calculate the z-score like we talked about. That's step 1. And then step 2 is find the area under the standard normal curve by using an applet. Now most of you can use this applet here. The only ones that may not be able to, we've tested this, is those that have older Macs, but I think we tested this with TAs and with teachers that most people can use this. If not, there's an older version of an applet that you can use. Either one of these 2 should work. And you can try it either using Google or Firefox, whatever web browser you use. Okay, so here's an example of how you can do this. A length of a human pregnancy from conception to birth is normally distributed with a mean of 266 days and a standard deviation of 16 days. What is the probability of a pregnancy that lasts less than 240 days? So step 1 is convert the value of x using the standard normal variable z. Okay, so first of all, we calculate it by taking the 240 minus the mean, which is 266 days, divided by the standard deviation, which is 16 days. When we solve for that, we get a z-score of negative 1.625. Okay. Now the step 2 is now we have the z-score. Find the area under the standard normal curve using the applet. So what I'm going to do is I'm going to escape out of this, and I'm going to get into the applet, and I'm going to get my z-score of negative 1.625. Press enter. Now in the problem it asks for find the probability that a pregnancy lasts less than 240 days. So what we do is that we shade, we can click and get the certain areas that we're interested in marked in blue, but we're only interested in less than, so if we click less than, this is the probability here that's associated with it. Okay, and so when we determine the probability, we conclude here that that there's a 5% approximate probability that a pregnancy will last less than 240 days. And here's an example of what I just did using the applets. Okay, let's do the next example here. So the length of a human pregnancy from conception to birth is normally distributed with a mean of 266 days, standard deviation of 16. What's the probability that the pregnancy lasts more than 270 days? Why don't you stop the recording, try to work these 2 steps out, and try to come up with it. Okay, so the answer to the z-score is z-score is equal to 0.25. Okay, finding the area, if you were to do this, is that if you go to the applet, you shade over to the right, and you type in 0.25 to get the answer. When you shade over to the right, you get an area of 0.401. So the probability of a pregnancy lasting more than 270 days is about 40%. So we're going to continue with one more example of this in the next recording.